Hey guys, my name's Amir and today we're going to be practicing some velocity and displacement graph questions. So we're going to be trying this question today. This question is kind of a strange one. You don't see many of these questions out there, which is why I want to try it. So this is a little bit of a unique question. I've done a lot of these questions before, and this is kind of a unique one, which is why I decided to do it today. So the question is, the graph that follows shows how the speed of an athlete varies with time as he or she sprints for 100 meters. So there's a key piece of information there. We traveled a distance of 100 meters. So they did give you a graph, so usually using a graphical method is the quickest way to solve this problem. It says calculate the time t, so find this time t for which the athlete accelerated. So let's kind of visualize what's going on here. The athlete is stopped, they start accelerating, they're speeding up, running faster and faster until they hit 10 meters per second, and then they hit a 10 meters per second. They can't go any faster than that, but they maintain that 10 meters per second and for 11 seconds during like a 100 meter sprint. So that's kind of what's going on. We want to know how long it's accelerating for, like how long did it take to reach that 10 meters per second. So I'll give you guys a second to think about how we're going to do this question. Alright, so if you look at it, the only two pieces of information we have is the distance and the shape of the graph. So can you guys remember what the relationship between velocity and distance is? Yes, so the distance corresponds to the area under the velocity graph. So we actually need to work out this area, and we know that the total area under this graph is going to equal to 100 meters. So we're going to work out the total area, so hopefully you guys can see it's the area of this triangle, which is half 10 times t plus the area of this rectangle. So the area of this rectangle is going to be 10 times 11 minus t. Now this value needs to equal to 100 because we're doing a 100 meter sprint. We can work this out and we'll get 5t plus 10 times 11 minus t. So that's going to be 110 minus 10t, which is equal to 100. So we can solve this and we'll get minus 5t is equal to minus 10, which means t is equal to 2 seconds. So hopefully you were able to do that question, and we're going to try another one real quick. So what is the magnitude of the acceleration of the object from minute 6 to minute 8? So I'm not going to draw the entire graph, I'm only going to draw the section that we're using, which is from minute 6 to minute 8. And we want to find the average acceleration given the position. So again, we want to remember our rules for this displacement graph, right? Position means another way of saying displacement. So we have the gradient of our position graph is going to give us the velocity. So whatever the gradient of this is, this gradient is actually going to be equal to the velocity. So if you guys can work out the gradient and see that it's equal to 2 divided by 2. So the gradient is actually going to be equal to rise over run. So we have 2 meters divided by 2 minutes. So in other words, 1 meter per minute. Okay, so that's our velocity. Now, remember, what does acceleration mean? We can't actually get acceleration by looking at the gradient of this. So instead, we're going to have to use our common sense and think, remember, acceleration is the change in velocity over the change in time. So we need to know how much the velocity is changing by. So let's take a look at the velocity during this time period and figure out how much it's changing by. So let's just choose any point here. At this point, the velocity we know is 1 meter per minute. And we know right here the velocity is still 1 meter per minute. Right? Remember, during this entire straight line, the gradient hasn't changed at all. The gradient is constant, so the velocity is constant. Now, if the velocity is constant, that means the velocity hasn't changed at all. And if the velocity hasn't changed at all, then our acceleration is actually 0. So the answer to this is the acceleration during this period is 0. I hope you enjoyed that video. If you have any questions, remember you can ask us at any time. Thanks.